I'm going to do one of the assignment problems. It's not part of your assignment, but it's within your assignment, and it's kind of like some of the other ones around it, but a little more difficult, so that hopefully the other guys will be a little easier. Okay, this is number 14 on page 248. I called it one ring to rule them all. So somebody want to do the Gollum voice?
No.
Chris do it.
No.
Chris, Jasmine, that's a really bad Gollum voice.
Chris.
Chris has got a good one?
What am I supposed to say?
I don't know. Something about Precious. Go for it.
No, I'm good.
You do it all the time in science. Be so shy, Chris.
Science, socials.
Okay.
No.
Let's read this. So a diagram shows two concentric circles with radii r and r plus 4. So let's try to decipher that a little bit. What is a concentric circle? Or what are concentric circles?
Perfect circle. Two circles.
A circle is a perfect circle.
Oh, a circle within a circle?
No.
Well, this is a circle within a circle. But what's the difference between that and something like this?
Oh, a perfect circle within a perfect circle.
You don't have to say the word
Oh,
perfect.
yeah.
A circle is already perfectly circular. What's the difference?
One's bigger than the other? I don't know.
You tell us.
One's
Yeah.
centered.
Centered. That's the key.
No.
This set of circles have the same center. This set of circles do not. So concentric circles have the same center. Got that? Okay. So let me just draw this again. So I've got two concentric circles. With the same center, and one has a radius r plus 4, the other has a radius of r. All that really means is that one circle has a radius that's 4 units longer than the other. That's what they mean by r plus 4. And we're being asked to find this area, this outer ring. How do we do that?
Find both and subtract.
Find the area of both and subtract, basically. Right? I would find the area of the larger circle and subtract the area of the inner circle, and the remaining piece should be that shaded blue region. Yeah?
Wouldn't they just be random?
Nope. I'm not talking, because we're finding the difference in their areas, not the difference in the radii. The difference in the radii would be 4. But I want the difference in their areas. So then this begs the question, how do you find the area of a circle?
Pi r squared.
Pi r squared, good. Okay. So the area of a circle is pi r squared. So, like Darren suggested, we're going to go the large circle and subtract the smaller circle. Okay, this is part A. I should also note that. Part A in your textbook just asks us to write an expression for the area of the shaded region. Okay, good. So, give me some thoughts here. How do I write an expression for the area of, say, the large circle? If the formula is pi r squared, how do I do that for the large circle?
Pi times bracket r plus 4 bracket squared.
Excellent, right? The radius of the large circle is r plus 4. So I just go pi r squared, or because r is r plus 4, I put r plus 4 squared. Everyone with me?
Yeah.
Minus the area of the small circle, which is
Pi r squared.
pi r squared.
Whoa.
Good? Awesome. So there's our expression for the area of the circle. That's A.
That's it?
For A, that's it. B, asks us to factor this expression completely.
Uh-oh.
What's the first thing I always look for when I factor? GCF, which is pi. You see that? What's left?
R squared.
R squared, and what's left in the first one?
R plus 4.
R plus 4 squared.
Yeah.
Minus R squared. Can you guys follow that? All I did is I factored out this pi, wrote it in front, and wrote what was remaining. So I have R plus 4 squared and R squared. Good? I don't want to lose you in the algebra, so. Okay, what kind of factoring do I potentially have here?
Difference one.
I potentially have difference of squares. Let's do the test. Am I subtracting? Do I have a difference?
Yeah.
Yes. Am I subtracting two things that are perfect squares?
Yeah.
Yeah. What's the square root of R squared?
R.
What's the square root of R plus 4 squared?
R plus 4.
Just R plus 4.
Whoa.
Does everybody understand why that is?
Oh yeah.
Good. Okay. So that gives me a final factored form of, you tell me. See if you can do it.
R plus 4.
R plus 4.
Minus or plus R.
Plus R. What about the other one?
R plus 4 minus R.
Good job, guys. Nice job. You got it, right?
Oh, I see.
I'm taking the square root of this guy. That's R plus 4. That's just this portion here and here. And then I'm taking the square root of the second guy. That would be here and here. And then plus minus. Good job.
And then could you simplify that?
Yep, and then we can simplify that a little bit further. So this becomes 2R plus 4 times
2R plus 4.
no.
2R minus
What would it be?
negative 2 negative.
These two R's just equal 0. They cancel each other. R minus R. So I'm left with just 4.
Indeed. But would you have to simplify it in that equation? Yeah.
Mm-hmm. We gotta simplify and factor as much as we can. Okay. Can I do anything more? I'm gonna bring that 4 out in front with the pi.
Just read it now.
Does anybody see one more thing that we can do? Everybody understand how I got 4 pi?
Yep.
I just brought the 4 in front.
Did you find the GC?
Yeah, is there a GCF in here?
Yeah.
Yeah, I gotta pull that out as well. What's the GCF there? 2. So 4 pi times 2 times R plus 2. And then I'm going to multiply these two together to give me 8 pi R plus 2. And that's all we can do.
Whoa.
Good? Now here's the beauty of doing that. For C, they ask us if the radius is 6 centimeters, meaning the radius of the inner circle. If that was 6 centimeters, tell me the area of the shaded region. That's a lot easier to solve now that we have this nice, simple formula versus doing it in this. You get the difference? Right? We would have to either use one of those two formulas. And it's a lot simpler to use this guy than it is to use that guy. You could use both to check, but this is a lot quicker. Okay? So they're saying, okay, R is 6. What is the area of that shaded region? Well, that would just be 8 pi times 6 plus 2, which is 8 pi times 8, which is 64 pi. And can somebody give me an approximation for that?
$201.06.
They want to the nearest tenth. So 201.1?
Yeah.
Okay. My units are centimeters squared.